Okay, next method is folding method. So here the key is partitioned into a number of parts. So the whole number is divided into some parts, K1, K2, etc., Kr. So R partitions are there, R parts are there. Each part, except possibly the last, has the same number of digits as required. So these parts are added together, ignoring the last carry. So in the last example also, we had done some like that. We had calculated one hash function by adding the digits. So here, h of k equal to K1, K2, K1 plus K2 plus etc. Kr, where K1 is the first digit, K2 is the second digit, and Kr is the last digit. And it is to be noted that you have to ignore the last carry. For example, consider this number 3205. So 3205 means here we are adding two digits, 32 plus 05. So 32 plus 05 means we will get 37. So hash function is considered as 37. So one can also reverse the first part before adding. That is, we can actually right or left justify. For example, some numbers are given. 3205, that is first key, and hash function is calculated by adding 32 plus 5. So we will get 37. Or we can calculate in another way. We can reverse the last two digits. That is, reverse last two digits means what will be the number? Tell me.
3250.
Yes. So hash function calculating hash function of 3250. So 3250 means we will add 32 plus 50. So you can either use 37 as hash function or 82 as hash function. Similarly, 714H. So you can just add the digits. That is 71 plus 48. That is equal to 19. Actually, we will get 119. We have to ignore the carry. So the number is 19. Hash function is 19. Or you can reverse the last two digits. Reversing last two digits means you will get 84. So 71 plus 84 means you will get 155. Ignoring the coefficient, ignoring the carry, you will get 55. So hash function is either 19 or 55. And the next number is 2345. So for finding the hash function of 2345, you can add 23 plus 45. So you will get 77. Actually, it is 78, not 77. 78, 23 plus 45. Okay, or you can reverse the last two digits. That is, reversing last two digits means you will get 2354. You can add 23 plus 54. That is, you will get 68. So hash function is either 78 or 68. So some variations of folding method. First one is pure folding. Pure folding means adding pairs as such. That is the first method. In this case, 3205 is the number. That means pure folding means 32 plus 05. That is pure folding. The next method is fold shifting. Means alternate positions are reversed before adding. And next method is fold boundary. Fold boundary means only n positions are reversed before adding. We will see some examples. Okay, first one, first key. Key is 1522756. Actually, key means a given number only. Okay, so we need to chop it. What do you mean by chopping? Means splitting. Actually, we are going to split this number into this number 1522756. This number is divided into some parts, into some pairs. So 56 is one pair, 27 is another pair, 52 is another pair. Lastly, you will get 1. So we are going to add 0. Okay, pure folding means you can just add these digits. That is 0, 1 plus 52 plus 27 plus 56. You will get 136. Then what we have to do? What is the hash key? We got 136. What is the hash key? Tell me. 3. 36. We have to ignore the carry. So pure folding means we will get the hash function as 36. Then next number 5499025 means we have to split it. 25 first pair, 90 second pair, 49 next pair. Then 5 remains. After 5 we will put a 0. So pure folding means adding all these things. 05499025. So we will get 169. Then next number 11943936. So 36 is one pair, 39 is next pair, 94 is next pair, 11 is next pair. So adding all these things, we will get 180. So the hash function of first number is not 11136. We have to take hash function as 36. We have to ignore the carry. Then in next number, the hash function, what is the hash function of next number? 5499025.
69.
Yes, 69. We have to ignore the carry. Then in the last case, we got the sum as 180, but we have to ignore the carry and we will get the hash function as 80. Okay, the next one is fold shifting. Fold shifting means, what is the method? Can you tell me the definition of fold shifting? We have to reverse the alternate pairs. Means first pair is 0, 1. So we had reversed it. It is 1, 0. Then the next pair, 52, you remind us it is. Okay, so 70 and 27. 27 means we have to reverse it. That is 72. 56 means no changes there. So we have to add all the pairs and we got 190. So 190 means, what is the hash function? 90. Yes, we have to ignore the carry. Again, the next number. So first pair is 05. We have to reverse it. Next pair, no change, 49. Next pair, 90. So we have to reverse it. So it will be 09, then 25. So add all the digits and we've got 133. So you have to ignore the carry and the hash function is 33. Next number, this number is actually 11. So reversing also, we will get 11 only. Next pair, no change, 94. Next pair, we have to reverse it. 39. So we have to reverse it. That is 93. Then last digit is 36. So we have to add all the pairs. You got 2, 3, 4. So what is hash function? Yes?
34.
34. Yes, we have to ignore the carry. Okay, the next method is fold boundary method. Fold boundary method means, tell me what is fold boundary method?
Last pair.
Yes, we have to reverse the last pair only. So the first pair is 10, no change. 52, no change. 72, 52 only, not 27. We have to reverse the last. Yes, mistake is there. This is, yes, boundary you have to exchange. Actually, this is correct. Boundary means first pair and last pair. What is the definition? Only n positions are reversed. First and last you have to reverse. This one is correct. First is 1 0 0 1. So you have to reverse it. That is 1 0. 52 no change. 27 no change. 56 that it becomes a reverse. That is 65. You got 154. So ignore the carry. Hash function is 54. So in the next case, first and the last you have to reverse. 0 5 becomes 50. 25 becomes 52. So add all these terms. You got 2 4 1. So ignoring the carry, the hash function is 41. Lastly, 1 1 reverse means 1 1 only. 36 reverse means you will got 63. Other pairs no change. So you add all these numbers. You got 2 0 7. And you can ignore the carry. So the hash function is 0 7. Okay, I think you got what is Pauli method. Any doubts? Sorry, next hash function method is digit analysis method. Digit analysis method. Hash address is formed by extracting the digits and rearranging them. So hash address is formed by extracting the digits and rearrange them. Rearrange in some other format. So for example, the key 6732541 can be transformed to a hash function 427 by extracting the digits in the even position. So we are going to extract the digits in the even position. So first even is actually the direction is very important in hash function. We are going to take the direction from right to left. So 0 is at the 1 is at the 0th position. So you can take it from 1 only. 1 is at the one first position, 4 is at the second position. So that means 4 is at even position. So first number is 4. Then 5 is at third position. Sorry, yes, 5 is at third position. 2 is at fourth position. Again, 2 is at the even position, so you can extract 2. Then 3 is at fifth position, you can ignore it. 7 is at sixth position, you can extract it. So the key is 4 to 7. The decision for extraction and rearrangement is based on some analysis. Here, an analysis is performed to determine which key position should be used in performing hash addresses. For each criterion, hash addresses are calculated and then a graph is plotted. Then that graph is selected, which produces the most uniform distribution. Okay, this is the algorithm. Can you view the algorithm? Okay, so input is a key value. It will be in the form of a string of characters, and hash address, we have to calculate the hash address. So output will be an index or it is a hash address. So here we are going to use a data structure, hash table. Hash table will be in the form of an array. So first, initially I equal to 1 and key value equal to 0. Then we will check key. This k of I is the final output actually. Sorry, we have to extract each and every digits in the key. So then we have to add, actually this algorithm is not important. We can skip it. Then about collision resolution techniques. Collision resolution, what do you mean by collision? Collision means more than one key is mapped to a single location. That is known as collision. Actually, one key is allowed in a particular index. So if there exists any collision, if there exists two numbers at a particular index, we have to remove it. So in some cases, the complete removal of collision is impossible, but we have to minimize the number of collisions. So removal of this collision is known as collision resolution techniques. So complete removal of collision is almost impossible. So whatever hash function is used. Example, birthday surprise. If there are 24 students in a class with same year of birth, so there is a probability that 50-50 chance that two students have same birthdays. So actually it is a universal fact, and this one is a collision. So collision cannot be ignored. Thus we can go for collision resolution techniques. So there are different types of collision resolution techniques. This one is an important essay question. Collision resolution techniques are majorly divided into separate chaining, that is open, or otherwise it is known as open hashing. And the next group is open addressing, or otherwise it is known as closed hashing. Again, this closed hashing is divided into linear probing, quadratic probing, and double hashing. So these are the different collision resolution techniques. First one is closed hashing, that is linear probing. So linear probing is under closed hashing method. So the simplest method to resolve a collision is closed hashing. Suppose there is a hash table of size h and a key value is to be mapped to an address location I. Then the closed hashing can be stated as start with a hash address I where the collision has occurred. Do a sequential search in the location I plus 1, I plus 2, etc. H. What is H? H is actually capital letter. What is H? Tell me what is H? H is the size of the hash table. Suppose there is a hash table of size H. So H is the size of the hash table and a key value is mapped to a location I. So suppose assume that at position I we are having a collision. So a hash table of size H is there. So assume that at location I a collision has occurred. So we have to search from I, then I plus 1, I plus 2, etc. up to H. So this search will continue until key value is found or an empty location is encountered. The search has reached the location where it is started. So you have to continue the search if either of these conditions exist. So here, one most important fact is that the hash table is considered as circular. That is why it is known as closed hashing. So we are considering the first method. Under closed hashing, we are having linear probing. In linear probing, first of all, you have to search. The technique is that you have to search in a straight line manner. So that is why it is known as linear probing. Probing means actually it is a comparison. So consider one example. Consider a hash table of size 10 and a hash function is defined as h of k equal to k mod 7 plus 1. So assume that the key values are inserted in the following order. Actually, the order is very important. If you are given some keys, you have to insert in the same order only. 15, 11, 25, 16, 9, 8, 12, 8. So the order is very important. You can't change the order. You can't first take 8, 12 like that. You have to take 15 first in the hash table. Otherwise, you will get different answer. So this is the simplest method to resolve the collision is to place a record in the next available position in the array. So suppose we got two numbers at the same index. Then to resolve this collision, we can consider the next available position. You can move one record to the next available position. So drawback of this method is that clustering occurs. That means some key values will be clustered in large group. As a result, a sequential search becomes slower and slower. So this kind of clustering is known as primary clustering. A cluster is a collection of index position which contain collided key values. We will discuss it. Okay, this is our number. Okay, actually, what is our hash function? Hash function is defined as k mod 7 plus 1. Remember that our hash function is k mod 7 plus 1. K, what is k? And the hash function is, what is the hash function? K mod 7 plus 1 if the index starts from 1. And it is equal to k mod 7 if index starts at 0. Okay, so first number is 76. What is the hash value?
1 ആണെങ്കിൽ k mod 7 മാത്രം.
1. Yes, 1. Index is 1. This 1. Here index is 0. 1 ആണെങ്കിൽ k mod plus 1. K mod 7 plus 1. 0 ആണെങ്കിൽ k mod 7. Got it? Hello. Okay, so here the hash function is k mod 7. So first number is 76. So 76 mod 7. What is the reminder? 6. So you can draw a hash table and put 76 at the 6th location. Okay. The next number is 93. 93 means again 93 mod 7. 93 mod 7 means value is 2. So at the second location we can store 93. Next number is 40. So 40 mod 7 means you got 5. So at index 5, fifth location we can store 40. Then next 47. 47 means again, okay, remember this case. 47 means 47 mod 7. 47 mod 7 means the answer is 5. At fifth location we had already placed one number, 40. So what is the location of this 47? Tell me, can you tell me? So at the location I, we are having a collision. At location 5, we are having a collision. So we have to search from I plus 1, I plus 2 onwards. So here I plus 1 is 6th location. It is already filled. Then what we have to do? Tell me. 6th position is the last position. Actually, linear probing means it is a closed hashing. Closed hashing means this hash table must be considered as a circle. That means after 6, you have to search at the 0th location. So actually, the 0th location is free now. So you can place 47 at the 0th location. Did you got it? Hello. We cannot place 47 at 5th location because 5th location is already filled. So you have to search from the next position onwards. Next position onwards means actually this hash table is a circular one. So after 6, there will be 0. So actually, after 40, the next location is already filled. So after 6, next index is 0. So 0th index is free. So 47 can be placed at this location. So next number is 10. So 10 mod 7. 10 mod 7 means what is the number? 3. So you can place 10 here. The next number is 55. So 55 mod 7 means you got 6. 6 means already this number is filled. This location is filled. 76 is filled. So you have to search from the next location onwards. Next location means 0th location is also filled. Then next location is first location. So you can put 55 here. Okay, got it. Okay, that's all. That's about linear probing. It is very important. So algorithm is like this. Hash table is an array of size, table size. Actually, hash table is considered as an array and the maximum size is table size. So first step, we have to read the value to be inserted. Then we have to initialize the value of I. Then index is calculated using this key value mod table size. Mod table size means that is actually here. Why here 7 is taken as mode? Because the table size is 6. 0 to 6. 0 to 6 means maximum 7 numbers are included into this hash table. So that's why we had chosen this 7 as mode. 7 as the size. So algorithm says that value mode table size plus I mode table size is the index. So index is calculated like this. If there is no element at that index, then you can insert. So first we will search. First we will check whether that index is filled. If there is no element at that particular index, we can store it directly. If there is already an element at that particular index, then we have to search from the next location onwards. If the next location is free, that is I is I plus 1. That means next location is free. Then again we will go to this step 4. So if I is less than table size, then you can go to again you can compute the next index. Like that we can continue. Actually, algorithm is not important. Okay, one more example. So suppose this is our hash table. The first one. This one is our hash table now. Suppose we want to insert one more number, one more key, 32 into this number. What will happen? So 32 means actually what is the size of this hash table? 13. 0 to 12 is the size of the hash table. So key is calculated. Hash function is calculated like this. 32 mod is 13. So you got 6. So at sixth position, already we have 44. So we cannot store 32 at 6th position. So we will check at the 7th position. 7th position is also not free. So we will go for 8th position. 8th position is free. So we can store 32 at this location. So one more example. Here also key hash function is k mod 13. key is 31. 31 means you have to save it at this location. Hash of 31 means you got 5. 5 means 31 must be stored at fifth location. Fifth location is not free. You will go for sixth location, it is not free. Seventh location also not free. Eighth location also not free. Ninth location also not free. 10th location also not free. 11th location is also not free. But 12th location is free. So we can store this 31 at the 12th location. One more example. So storing 19. Hash of 19 means location is 6. But we cannot store at 6. Search 7. 7 is filled. 8 is filled. 9 is filled. 10 is filled. 7 is filled. 12 is filled. After 12 we have to go for 0th location. Like that you have to continue. Okay. Okay, we will stop it here.